I'd like to begin this class with a clip by Thomas Sowell on global warming manufactured by intellectuals. He's done some books concerning intellectuals, and he's kind of on the same page that I am, and then I'll continue on with my own thoughts.
Some people in learning institutions will do anything to get grants or funding for research from corporations and or the government. Some corporations will also do anything to get funding and grants and or subsidies from the government. Now these people do not have to lie necessarily. They just merely present the data from a biased position. For those of you who did not go through my physics class, let me give you a short example for clarification. Now, the global warming advocates would state that increasing CO2 levels that result in global warming is caused by human intervention. Now, that is a true statement from one perspective, but it is a relative position. So what I try to do in that physics class is show you both sides. There's usually two relative positions, but there's also an absolute reality. So we're going to try to find out what the absolute reality is, because there's other people that would say, for instance, a natural scientist states increasing CO2 levels that result in global warming is caused by natural phenomena. So that's also a true statement, but from one perspective, which is a relative perspective. So what I try to do is try to take everything that I see, and it seems like the ones on the right here, to my right, seem to be winning the war. They're the ones that are saying that it's caused by human activity and intervention. So let me try to give you the absolute. The absolute is increases in CO2 level that result in global warming is caused by a combination of human activity or intervention and natural phenomena. So that's true in all situations. That's the absolute reality. The question is, how much of one or how much of the other? That's what I want to look at. And I'm not going to have all the answers, but I'm going to give you some of the data so you can help determine the answers with us or with me or together. Thank you.
Let me begin with looking at the temperature between 2016 and 2019. There was a significant increase in global warming. So what I hear them saying is that they're trying to make a correlation between global temperatures and global CO2 levels. But as you can see, the CO2 levels around the world are fairly evenly distributed, except in Russia and parts of China, it looks like. But the temperatures seem to be more focused on, of course, the areas that can fluctuate the most for temperature, and that would be the cold areas up in the northern tundra. However, the temperature ranging does not correlate with the CO2. So I'm looking at why are these areas, not just the polar cap, but down into certain parts of Europe and China and some of these areas, and I'll talk about that in a minute. Let's talk about temperature variation. The same amount of heat in the desert will not significantly increase the temperature of the desert area that is already hot. However, the same amount of heat increase in the cold climate will have more of an effect on the cold environment. So let's go back to that clip that I had. So anything above the red line, of course, is going to heat up faster or more significantly than anything below the line at the equator, the temperate zones. Therefore, this map doesn't really tell us anything significant. Global warming will affect the colder regions more than the hotter areas is a given. Now let's look at gases, the density, molecular weight, and the chemical formulas of some of the common gases. This table that shows those, and what I pulled out are the ones that are actually in the atmosphere that we're talking about. The number one most abundant is nitrogen. 78% of all the atmosphere is nitrogen, and it is the lightest. Next is oxygen at 21%. It is the second most abundant, and it's the second lightest of those things that are in the atmosphere. And that makes up 99% of the atmosphere is nitrogen and oxygen. Next is argon at 0.93%. That leaves the rest of what's in the atmosphere at 0.07%. and of that, half of that is carbon dioxide. So carbon dioxide is just a trace amount of the atmosphere. 0.035% of the atmosphere is carbon dioxide. And of the four major gases, which it is a trace amount, it is the heaviest. So it would want to fall. It would want to stay at a lower level. So I just can't believe that we're putting so much emphasis on carbon dioxide as a greenhouse gas. There's such a trace amount, and it's the heaviest, which means it would fall. That's hard for me to believe, but I'm not a scientist. But I'm just telling you from a novice, this seems somewhat suspect. And here I've highlighted some of the other trace gases that are in the atmosphere, all of which are lighter than carbon dioxide. And one I want to mention is specifically is methane, because I think methane has a lot more to do with perhaps global warming, just as much or more than carbon dioxide, because it is a lighter gas. It's going to be up in the higher atmosphere. And the fluctuation in methane, I think you need to do some research on that, which I did not do, but I just know that through the history of methane in our atmosphere has changed it somewhat significantly. Now let's talk about lakes. Eutrophication of lakes will significantly increase greenhouse gas emissions by the University of Minnesota. In summary, the greening and eutrophication of the world's lakes will increase the emissions of methane into the atmosphere by 30 to 90% during the next 100 years, says researchers. This increased methane emission is equivalent to about 18 to 33% of the annual carbon dioxide emissions from burning fossil fuels. Limiting lake greening is important to preserve fragile water supplies and to avoid acceleration of climate change. I brought this out because it really talks about methane. Methane is one that really fluctuates a lot. So I just thought that was kind of interesting how they believe methane is going to increase to at least about a quarter of what the annual carbon dioxide levels are. Here's an article from 2015. The northern lakes act as carbon dioxide chimneys in a warming world. Many of the world's approximately 117 million lakes act as wet chimneys, releasing large amounts of greenhouse gas carbon dioxide into the atmosphere. The most recent estimates show that the carbon dioxide emissions from the world's lakes, watercourses, and reservoirs are equivalent to almost a quarter of all the carbon dioxide produced by the burning of fossil fuels. And this is just from lakes. Here's an example of people trying to control the release of methane gas caused by natural phenomena. So this is Wikipedia just talking about this big gas crater. Geologists intentionally set it on fire to prevent the spread of methane gas, and it is thought to have been burning continuously since 1971. I just want to give you an example of just how much methane and CO2 are under our feet. They have nothing to do with human intervention. So let me just kind of summarize one thought that I had in my mind here. Okay, so CO2 makes up approximately 0.035% of the atmosphere, which is a trace amount. And we've also talked about how it's a heavy gas, so it's going to stay at the lower levels. But the one thing that I want to make sure everybody understands is this is a closed system. The Earth is a closed system. In other words, we have an atmosphere that keeps everything in here. And there may be some of the higher or lighter gases that seep out, but I cannot see CO2 seeping out because it's a heavy gas. It's going to stay at the lower levels. So it is part of a closed system. Another way of saying this is that the form changes from being either in living things such as plants to being in the atmosphere. So CO2 is constant. It's just how it's where it is as far as the form in which it is. It's either in living things or it's in the atmosphere, but the relationship between those two is constant. There's a direct correlation, a balance between those two. There's one website I don't even want to mention it because I just some of the stuff that's so bizarre. But it shows that the measurements taken from above Japan late from 1985 to 2000, it shows that CO2 parts per million increased significantly. Of course, they want to show that CO2 significantly increased during the Industrial Revolution. And of course, the people here in the United States want to focus on this reports such as that. But then I thought, well, wait a minute, what's to the uh, west of Japan? Because weather usually flows from west to east. Well, it's China, of course. And what's the biggest polluter in the world as far as CO2 emissions? Is China. So with the weather patterns going from west to east, all that CO2 and pollution and stuff would go from China right over Japan. So I'm not saying that CO2 levels haven't arisen around the world since the Industrial Revolution, but I do become somewhat suspect in the amount and some of the studies that I've seen. Now let's talk about the cycles of this Earth that we humans have absolute no control over. For instance, the 100,000-year elliptical orbit, the 41,000-year tilt, the 23 to 26,000-year gyrates. For instance, I think that most of the people believe that the ice ages are more to do with the tilt because they happen about every 40,000 years. But these are cycles that we humans have absolutely no control over. So we cannot say that we are the cause of global warming. Yeah, there seems to be a problem as far as a lot of the studies that I've seen. They're confusing global warming with CO2 levels. CO2 levels may have some effect on global warming, but it does not have all the effect on global warming. Global warming, primarily to me at least, is determined by our proximity to the sun. Although there may be more cycles than these three, the orbit, the tilt, and the gyrates. Let's just take these three. Everything below the red line will be considered an ice age, and then you have the 100,000-year cycle, the 41,000-year cycle, and the 23,000-year cycle. And so each of these, every once in a while, these will overlap. For instance, these three overlap cycles of called in warming periods, upgrade causing enhanced warming, and then there's other times when it's on the downslope, which signifies that the cooling area. So when two of them overlap, that's an enhanced cooling area. So the point is that I'm trying to make is where are we in these cycles? If we're in an upswing, especially if two are overlapping, it could be a significant, and there is nothing we humans can do about it. As you can see, I also added the 11-year sunspot cycle, which is a relatively small cycle compared to the others, just to show you that there are times when it could be 5.5 years of hot, 5.5 years of cold due to the sunspots, and so we may be in an upswing just because of the sunspot cycle. So a lot of these things I don't know, but I do know that the cycles have a lot to do with the warming of this Earth that has nothing to do with human intervention. Now, there are a whole bunch of other cycles. I took the three big ones, but there's also temperature of the sun cycles, sunspot cycles. There's a sunspot cycle of about every 11 years, which is a fairly relatively short cycle. And it's also, for instance, how much influence does the temperature of the sun have on what happens here on Earth? It is estimated that a drop of just 1% in the sun's output of radiation would decrease Earth's mean global temperature by more than 1 Kelvin, which is 2 degrees Fahrenheit. The entire Earth would be covered with ice if the sun's radiation decreased by only 6%. So there's so many factors out there that are controlling our global Earth's temperature and climate other than just what we humans are doing. And there's nothing that we can do about this. Continue on with the sun's impact on climate change. qualified for the first time by the Swiss National Science Foundation. But since we have been observing a consistently strong phase since 1950, it is highly likely that we will experience another low point in 50 to 100 years' time. It could be every bit as intense as the Maunder minimum, which brought particularly cold weather during the 17th century. Also includes, we know that the winters during the last minimum were very cold, at least in Northern Europe, says Schmutz. The researchers still have a fair amount of work to do before they have a detailed understanding of the relationship between solar activity and the global climate, both in the past and in the future. There's still a lot of work in this area, but these guys, this is telling us that there's possible cold air times coming in the future. So there's a lot of study still being done between the correlation between solar activity and global climate. To these guys saying that global warming is going to continue on for indefinitely and we're in dire straits, I think is suspect. So here's another study from natural sources. Most of the rise in CO2 likely comes from natural sources, the carbon cycle, nature, or nurture. It is 10 times as likely that atmospheric CO2 is coming from natural sources, namely the warming ocean surfaces, as it is likely that it is coming from anthropogenic sources. The changes in the CO2 track ocean surface temperatures, not global carbon emissions. Burning fossil fuels is not increasing atmospheric CO2. Recovery from the Little Ice Age driven by the sun is causing the oceans to release CO2. It is temperature driving CO2 release, not the other way around, just as it has always been. As the sun gets quiet in the next few years, sea temperatures, surface temperatures will begin to fall and the rise in CO2 will cease. If the sun stays quiet for 30 or 40 years, ocean surface temperatures will fall enough to reverse the CO2 rise. The globe will enter a new little ice age and things will get really interesting. So you see here, this is where I'm standing. I believe that the natural resources overwhelm us. I mean, we're so insignificant in the amount of first of all global warming, because that's all associated with our proximity to the sun, and which is separate from CO2. And then the CO2 levels themselves, though, are so significant from natural sources versus human sources, especially just the burning of fossil fuels. Now, there's been some talk about if we had less trees, it would be actually a cooler. So we should just cut down all the trees. But of course, now the Amazon, if that's true, then the Amazon you'd think would be really hot with all the big leaves, the broad-leafed Amazon. But you can see just south of the Amazon is really a hot spot where there's obviously less trees than the Amazon, but it's a hotter spot. So that thinking is kind of thrown out the window. And so we'll talk more about that. So what are the effects of trees on the climate? Well, they cool the earth by absorbing carbon dioxide, which is the big thing we're talking about reduction of the CO2 in the atmosphere, and by evaporating water because it makes clouds. But they also warm the earth, according to some of these guys, by quite a bit by absorbing sunlight with their dark green broad leaves. Now, some of these articles, there's two things that aren't mentioned. The shade that the trees provide keeps the ground under them both cooler and moister than if they were not there. This counteracts the absorption of the sun by the dark green leaves that increases heat. I mention this because of numerous articles that I read that state that it would be cooler if we cut down trees. These are articles printed in peer-reviewed publications. I try to only mention positive references for fear of lawsuits. However, do your own research. Type something like cut trees, cool planet, or plants and global warming. Be creative in your research and think. In some of these articles, you will find a trend that moves the focus of the benefits of the tree taking in CO2 and expelling oxygen, which is good, to the negative that higher CO2 levels causes the tree to release less water vapor. I suppose once that is proven wrong, they'll move to something else. So think about it. They are trying to figure out how to make the trees the contributors to global warming. Now, here's another thing to think about. I have read several reports and peer reviews that state trees in areas that have a lot of snow cause global warming because the leaves absorb heat and the shade keeps the snow from reflecting the sun's heat. I live in Florida, so I'm not an expert in the area. However, when I see snow, the trees are covered also. In addition, in northern areas, trees either have small leaves like pine trees or they are deciduous. I'm not aware of any broadleaf evergreen trees in the North Pole, for example, other than those that are deciduous. Deciduous trees lose their leaves, which allow the sun rays to pass through to the ground. Now, when the snow falls, then the pine trees are covered and will remain covered until the temperatures rise enough to melt the snow on the trees and the ground. By the way, it is possible that the snow will melt slower in the shade of the tree than the ground that it is in direct sunlight, which means that the trees are prolonging the cooling effect of the snow. Just something to ponder as a possibility. I'm not saying that my thoughts are the best. I am only thinking outside the box to stimulate your thinking so that you will include my thoughts in determining the truth. I believe some of you will produce the solutions. I just want to be a part of the process of stimulating critical thinking. So let me talk a moment about natural storms that destroy vegetation. And you say, what does that have to do with global warming? Well, there's tornadoes and there's hurricanes and such high winds that break trees, push trees over. For instance, I live here in Florida, so in Hurricane Michael shreds trees, crops from Florida into southern Georgia from 2018 by Jonathan Bells. Some 4 million acres of timberland were destroyed by Hurricane Michael in Florida and Georgia. The price tag of losses from the two states in timber alone is set at $2.3 billion between the two states. Now, I had an opportunity to drive down I-10 right after that happened, and it's just amazing how many miles and miles of just timber. It's all been stripped. The land's just been stripped. They've been broken off there, and the timber's just laying down there trying to harvest some of it, but most of it's just going to sit there and rot. So you not only have the rotting of those trees that causes CO2, and then you have the loss of all that vegetation that takes out CO2 from the atmosphere. So that's natural disaster, has a lot to do with CO2 levels, not human, has nothing to do with humans. Why do humans exhale CO2, carbon dioxide? We eat vegetation and our bodies burn the vegetation to release the energy and the CO2. It is no different than a car or a forest fire that burns vegetation that releases energy and CO2. The main difference is the body uses chemicals to burn the vegetation. To take in oxygen and exhale CO2, and the plants take in CO2 and exhale oxygen. We live in a balanced universe that includes balanced nature. The Earth can only support so many people before we can reach the homeostatic plateau. The Earth will strive to stay in balance. Those of you that took my physics class know that I focused on the balanced universe. Well, this is part of that balanced universe, balanced with nature, made for human existence. We have this cycle, a perfectly balanced cycle. We humans, though, sometimes mess up with this balance of the cycle with this urban development and overwhelm the vegetation's ability to be able to filter out that CO2 and give us back some more oxygen. So what I look at now are forest fires and the release of CO2. This is taken from British Columbia publication. So how does CO2 emissions from forest fires compare to those from fossil fuels? The initial, albeit unofficial, estimate is that the direct fire emissions in 2017 were about 150 plus or minus 30 million tons of carbon dioxide. This is 2 to 3 times more times the emissions from fossil fuels burning from the all sectors in British Columbia. But the impact of the atmosphere are even greater because the many trees killed by the fires will decompose over the next decade, releasing more carbon dioxide into the atmosphere. Also, trees killed by the fires will not be removing carbon dioxide from the atmosphere as living trees would. Therefore, the combined impact on the greenhouse emissions balanced in larger is larger than just the direct emissions. Fortunately, most of the trees affected by forest fires will regrow in the future decades and remove carbon dioxide from the atmosphere again. So this is really good. It emphasizes the fact that the emissions from forest fires can be as much as 2 to 3 times the emissions of fossil fuels from the entire British Columbia area. And the impact is not just the emissions from the fire itself, but from the decaying of those fires and from these trees, and the they're not removing the carbon dioxide from the atmosphere. So it's kind of a combined impact of forest fires that that seems to have more effect than just the burning of fossil fuels. So let's talk about volcanoes for a second. I know a lot of people say, "Well, John, there's not that many volcanoes on the Earth," and the people that do talk about it in the publications and the peer reviews and all this stuff talk about how volcanoes put up a lot of ash, and it actually has a cooling effect because it blocks the sun's rays and just a whole bunch of stuff like that. And I'm thinking, well, wait a minute. Most of the volcanoes are, I mean, most of the Earth is covered by water, so most of the volcanoes are under the water, and they're constantly spewing CO2, and they're not creating cloud cover, so they don't have that cooling effect. Um, so I just there's just kind of once again seem to be a lot of biased information concerning volcanoes, and again, there's nothing that we humans can do about volcanoes. And here's a website that I would like you to look at. This looks very convincing to me. He's a nonprofit, uses his own money, and sometimes I am leery of people that receive funds and grants from universities, corporations, and/or the government. Many of these are legit, but require extra scrutiny because of the bias in order to get the funding, keep the funding flowing. But this guy is not looking for funding. This is just his data, and it's pretty good. I really liked it, and to show you that this whole Earth, I mean, underneath the crust is all this activity of heat and CO2 pockets that we have no control over. One area I'd like to see more exploration in would be geothermal energy creation versus just solar panels and wind power. I think there's a tremendous amount of heat under our feet that could be used because primarily energy comes from we have to have heat to produce energy, and there's a tremendous amount under our feet. Whether we drive a big pipe down there and get some of that heat coming up and throw some water on it to create steam, I don't know what the solution is, but someone needs to be working on that more extensively and put some of this money that's going towards solar power and wind power towards geothermal. The largest continent on Earth is Antarctica. It also has the same heat source under it from the crust to the core. I wonder how many volcanoes are under Antarctica. So from this website, we get the giant volcanoes lurk beneath Antarctic ice. The expanse of buried volcanoes raises the question about the future of the ice sheet. This is from this mountain, the world's southernmost. Is a picture of that one, but then it goes on down. Lurking underneath Antarctica's ice are 91 volcanoes that until now no one knew existed. This may be one of the most extensive volcanic regions on Earth. The discovery isn't, however, just a fun factoid, but about the planet's southernmost continent. It's got scientists wondering just how active these volcanoes are. For instance, the volcanic heat might speed the shrinking of Antarctica's already endangered ice. So let me get this straight. So they knew about 47 volcanoes, and now they discovered 91 more. That's 138 volcanoes. It seems likely that at least one is active. So I know today, for instance, if a big sheet of ice breaks off from Antarctica, everybody says, "Oh, global warming! It's all because of burning of fossil fuels." Well, I wouldn't be so fast to jump to that conclusion, knowing that there's 138 volcanoes underneath that sheet of ice. Perhaps one or two, it would seem like likely that it would be active, and perhaps that's what's causing the heating and the melting of the ice from below. So prove that to me. Show that to me. Where's that evidence? Everybody wants to, like I said, focus on fossil fuels, burning of fossil fuels, which is an insignificant aspect in the whole scheme of things, but natural phenomena is huge. And I'm not sure that people have gotten to you as far as the power and just the incredible heat source and pressure and stuff that's underneath us. Let's look at Mount St. Helens. Within 3 minutes of the volcanic eruption, the lateral blast, which traveled at more than 300 miles per hour, scorched 230 square miles of forest. Tell me that humans can do that. I mean, that's fossil fuels doesn't even touch that, and then that's just scorched. I mean, you talk about the amount of heat and the amount of CO2 that's obviously was released from that. It's just incredible. I hope people look at this and look at Yellowstone volcano down below. More than 170 earthquakes hit and will Yellowstone erupt. This is a good one just to give you the magnitude of what's happening under our feet. And these are two just super type of volcanoes. But what's happening under the ocean? What's happening under Antarctica? Is there a super volcano under there? We don't know. It's just there's so much that we don't know about this own Earth that we're sitting on. And yet these guys are making all these predictions about 12 years from now the Earth's going to end. Well, I don't think so. If it does, it has to be more with population and we reaching the homeostatic plateau than it is the burning of fossil fuels. So I mentioned how if you looked at that article on Yellowstone, the guys are there, oh faithful. You realize how many earthquakes are associated with these volcanic activity. And there's also earthquakes, for instance, in this article, we measured the level of carbon isotopes present in the sediment during and after earthquakes to show that earthquakes on the fault produced over 43% of the carbon in the biosphere released from the Alps, according to this Dr. Horwath. So there's a lot of stuff going on, a lot of things that are happening that are totally out of our control. And earthquakes are not from fracking. I hate this. How can I get this across to you? Fracking may, like I said, cause us a few little shakes here and there, but overall, these earthquakes have been going on before the Industrial Revolution. They're continuing on now, and there's nothing we humans can do about it. I want to talk about road color. Here in Orlando, especially around the airport, they took roads that were fairly light in color around the airport and paved them with the darkest black asphalt that they could find. And the temperature difference I noticed was a significant difference, and plus the extra wear and tear of all that heat on the tires. But what they're saying is that there's a lot of CO2 that's being produced by these cement plants where they make the cement versus the asphalt. Um, but I'm thinking, well, but still the variation between the heat ratio between the lighter colors and the darker colors around Orlando area, because they're doing a huge project on I-4 right now, is significant. And all the miles of road that they have around the United States, that they're paving them all with black asphalt, it will increase the heat index of the world if they're doing it all around the whole world, especially in the urban areas. Once again, we're talking about this urban islands of temperature and CO2 concentrations. It's going to make it even worse. So I just can't see that. Oh, sure, these cement plants may be putting out some CO2 in order to create the cement, but then that concrete or that cement will be there on the roads for many, 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 many years, and so the differentiation between the hot of the asphalt and the cooler of the seems to me to offset all that in the long run. I hope you follow all that. What I don't like is all the bias. I mean, trying to do some research on the cement plants. Um, it's all everything is biased. I have to go down maybe 6, 7 pages in order to get something that's not so biased and so a little more balanced. Because in some of the things I'm talking about there, they look at cement causes runoff. Why you have asphalt? You're still going to have runoff. I mean, what's that got to do with it? It's just so bizarre. They try to do everything they can to beat up cement, and they want to put down this asphalt, and it's almost like they have an agenda to make the environment hotter. So let's talk about our humans, the actual human body. We are 98.6 thermal units, so we're walking around heating, and we're also inhaling oxygen and exhaling CO2, carbon dioxide. And we do this heating up and the release of carbon dioxide into the atmosphere. We do it 24 hours a day, 7 days a week, 52 weeks a year for our entire lives. Now, looking at that data from NASA from 1884 to 2019, I couldn't find any of the population of 1884, but I did find in 1886 there's about 1.5 billion. So let's just take the current from 2019 population of the Earth was around a little over 7.7 billion people. Subtract out that 1.5 billion. We have increased since 1886 till now, till 2019, about 6.2 billion more people at 98.6 thermal units living on Earth, each taking oxygen in and expelling or exhaling carbon dioxide. So now if we take the year 1884 to 1900, let's say 1.6 billion, and of those, 30% of them were living in urban areas. So the urban dwellers totaled about 48 million people. So that's then in 2019 we had 7.7 billion, but 56% of those were living in urban areas. So now we have 4.3 billion more people living in urban areas than in the 1886 or the 1900 time frame. That's almost 90 times as many people live in cities in 2019 than in 1884. And that's significant. That's not including taking in, of course, the heat of the bodies and the CO2 exhale, but also the heat from the buildings, the extra buildings, the asphalt, and cars, etc. To further this point, let's look at the urban heat increase from 1875 to 2019 in New York City. In 1875, approximately 1 million people lived in the city, and in 2019, a little over 8.7 or approximately 8.7 million. So that's a significant increase of people, more thermal units, breathing out CO2 concentrations. Now, what if instead of having those 8.7 million people confined to one area called New York City, that those people were actually spread out throughout the whole state of New York? So that makes a significant difference. So that the concentration of heat and CO2 in urban areas versus distributed throughout the country in rural areas where the nature can assist with shade, filter, evaporation. This human-made situation adds to global warming. So what I'm trying to say is that if we distribute the people more evenly, nature can take care of it through our vegetation. But because it's so concentrated in one area, we create these islands of heat and CO2 that contribute to the global situation right now. So a lot of it has to do with urban living. Although correlation between carbon dioxide and temperature seems to be implied. I see a lack of correlation between global temperatures and the global CO2 levels. Remember now, these are not satellite imagery, because it begins with in the 1800s, and obviously they didn't have satellites back then. So this is data that they're collecting and putting in some type of algorithms, and uh, so it's not actual satellite imagery, which I would love to see. But as you can see here, just off of the United States, off north, just off of New York City, you would see that there's a hot spot right there on the temperature, but there's no extra carbon dioxide in that area. I wanted to see apples to apples where the hot spots are, and it increases global warming in that particular area. That would be beneficial, but this tells me nothing. And during the summertime, when trees flourish with full growth, there is less CO2 because there's more foliage to filter it. During the winter, when there's less foliage and less filtering, results in more CO2 to go into the atmosphere. So this is another critical thing about urbanization, because urbanization, it seems to be the big ones. For instance, like New York City is in the north, and when the winter comes, the trees lose their leaves, and so that even makes it even worse for them, and in my opinion. I also included this article that says CO2 does not cause global warming, just to give you the other side of the issue. So the main target of CO2 emissions is from fossil fuels. But that's not a problem where the vegetation can filter the CO2 emissions. CO2 emissions are not bad for plants. Think of CO2 as plant food. Plants eat CO2 and excrete oxygen. It is only bad when the CO2 overwhelms the vegetation's ability to filter the high concentrations, like in the urban areas. So that's one of the aspects. If we had uh, a lot of people spread out over a large area where there's vegetation, you can have cars, and the cars can compensate, but they like that CO2, and it's a good mix of CO2, and they'll thrive on that CO2. It's not bad for the vegetation, and the vegetation can filter that CO2 and make it into oxygen. Um, but it's only a problem, primarily a problem in the urban areas, when you're so concentrated with so much CO2 that it overwhelms the vegetation. The vegetation can't filter all that CO2, and that's when the CO2 goes up, and the excess goes up into the atmosphere. So it's, again, the urban areas that are difficult, not the rural areas. So in summary, I just don't believe that humans' activity is the primary cause of global warming. It's obvious the cycles have a tremendous amount of influence on this, including those three big ones, and solar cycles, and a lot of other smaller ones, plate tectonics, volcanoes, earthquakes, and of course forest fires. Some of those are just heat from the sun, our relationship to the sun, and others have to do with from the crust down to the core, which is really hot, that's underneath us. And so all of these things contribute to not just the heat, that has nothing to do with CO2 whatsoever, but there's also the CO2, a significant amount that comes from natural phenomena. Now, as far as humans are concerned, yes, we do have the fossil fuels, and the deforestation of cement plants and road color. But it seems to me, as I read a lot of this information, when they start talking about fossil fuels being the cause of global warming, and it's one of the aspects of it, but then they'll include like deforestation and cement plants, as if that's all connected to the burning of fossil fuels. The focus is on fossil fuels. All human interventions seem to be focused on the primary culprit being fossil fuels, and I disagree. I disagree. Fossil fuels have nothing to do with deforestation. And so when I started thinking about this, I said no, so I rearranged it to show you that it's actually population that's the main cause. Remember, from 1885 to 2019, 90 times increase in urban living. That is significant. So the population has increased tremendously around the world, and the concentration in the urban islands of temperature and CO2 concentration is what really is the culprit around the world, and especially here in the United States. I gave you the example of New York City. So we're overwhelming the Earth eventually by reaching this thing called the homeostatic plateau. This Earth can only hold so many people and withstand so many people. Our primary objective should not be fossil fuels. That is a minor aspect of the whole situation. Our primary objective should be population control and spreading out our populations into get them away from such big urban areas. Those are the main culprits of CO2 emissions and heat increases around the world. It has to do with population. So fossil fuels, working on that, and alternative energies is a noble effort, but it should not be the number one. The number one should be population. Anything else, if we put fossil fuels number one, that to me is motivated by grants and funding and tax breaks and credits, but it's not for what is best. And then to prove that, I kind of wonder if Tesla were here and could give us free energy. I wonder how the banks, politicians, corporations, universities would treat him. I'm not sure anything has changed. It is more about money and power than what is best for all the people in the environment. Because what they did to Tesla, JP Morgan was funding him, and he pulled the funding away from Tesla because he could not figure out how to make money off of free energy. He not only took the money away from him, he tore down his tower to make sure he didn't build it. And so I don't think anything's changed. If someone came up with free energy today, we'd see the true colors of these people that are pushing these alternative energies. I believe that, again, the number one thing that we should be focused on is population and the density of that population.
In my opinion, population control is the number one thing that humans can do to preserve the balance between humans and nature. Increasing population results in an increase in the number of cars, roads, buildings, cement plants, deforestation, etc. The second concern is the increase in population into cities of concentration that overwhelms the local environment. Humans are not the cause of global warming. The natural phenomena has been heating and cooling the Earth in cycles well before the Industrial Revolution. CO2 is a trace gas that is in the atmosphere and is the heaviest of the main gases in the air. I cannot see that at high altitudes that the amount of CO2 is significant. It will fall due to its weight. Circulation may cause some CO2 to reach a higher level. However, overall, CO2 will remain at a low level. Making CO2 a trace heavy gas, the main culprit of global warming is motivated by the quest for funding, grants, credits, etc., but it is not backed by true unbiased science.
So in my opinion, if we look at CO2 levels, there's a certain amount of CO2 that's in the atmosphere. I think that the majority of that CO2 that's in the atmosphere comes from natural phenomena. Humans have some aspect of that, but only a fraction of even what the humans do is from fossil fuels. So fossil fuels is a very small fraction of what's actually happening as far as the CO2 levels. And then as far as global warming, there's a lot happening as far as the warming. For instance, there are close proximity to the sun, heat from fires, all this heat that's being produced from underneath, like when there's a volcano and stuff, all this lava, and then the heat that's rising up from beneath. So from the heat from above and the heat from beneath, vast majority of that, almost all of it, is from global warming, is associated with natural phenomena. Humans contribute some to that through deforestation, which has nothing to do with fossil fuels, also cement plants, and we do contribute through our just breathing out this, just walking around as thermal units. So we do contribute as humans, but it's a very small amount to the actual warming of the climate. So what we're doing is we're confusing global warming with CO2 levels when natural phenomena but has both significance on global warming and with the CO2 levels is, in my opinion, basically primarily a natural phenomena. So here again, we look at it from a relative perspective. Is increased temperatures causing an increase in CO2 levels, or is increased CO2 levels increasing temperature? In my opinion, the close proximity to the sun is the primary source of our heat, and it is through cycles. It's been going on before the Industrial Revolution. There's going to be heating and there's going to be cooling associated with the sun, and that is an increase. If it is increasing, the temperatures increasing due to our proximity to the sun, it will increase CO2 levels. To say in reverse, to say CO2 levels because of a human increase in carbon dioxide because of a burning of fossil fuels is a farce, in my opinion, because CO2 levels in comparison to the effect on the overall environment is insignificant, especially the part that's associated with fossil fuels. In light of the discussion by Thomas Sowell, there's a difference between wise and intellect. Some people are very intellectual, book smart, but not necessarily wise. And so I came up with this term. I believe that's is one that I like. I believe that there are many unwise intellect. These people have a tendency to be indoctrinated, perhaps, but they aren't really doing what I consider critical thinking. So this is what I've come up with. So if humans are not the cause of global warming, the question is, how much do humans contribute to global warming? Are we talking about global warming or CO2 emissions? Then split the data into categories so that we can see where the emphasis should be placed. To bundle two or several items together and blame the total on one aspect, fossil fuels, is not fair reporting. I see these distortions as biased political, economic considerations, but are not necessarily the whole truth. So what is the truth? And in closing, I just want to say that I am a believer in God, and I believe that God gave us dominion over the earth. We are allowed to use the resources that are available. However, He also made us caretakers of the garden, and there needs to be a balance between these two. So in closing, what I am saying is that it's a noble effort to try to find alternative energy sources other than the burning of fossil fuels. I believe that that can be happen and will happen, but I don't think we should be lied to and money thrown at stuff just because of false information. Quit lying to the people. Let's give adequate and correct, accurate information from both sides of this issue. We, the people, want to know what the truth is so that we can be part of the solution. Give us the information and let us do critical thinking to try to come up with the solutions. Hopefully, you have taken some of my information and added it to your understanding of things so that you can help be part of the solution. All I'm trying to do is stimulate critical thinking. I don't have to be right. I just want to be part of the solution. Thank you.
And now you know more of the story. Stay tuned. This is John McCamick with Truth University. Good day.